So tonight we are working on this 2011 Porsche Cayenne. It's a base model, and the customer's complaint is that the check engine light will come on every so often and go off on its own, but eventually it does return and stays on for some time. As far as if it affects anything on the drivability, it has not. They say it starts and drives the same. They haven't noticed anything. So first things first is that I'll get you a shot of the trouble codes. And in the engine computer, this is what it currently has stored. You can obviously see that it's both codes are related to something to do with the fuel pump. As far as which one, this does have a high pressure pump and low pressure. This is all related to the low pressure fuel pump. Obviously we've got one, the 3044, it's listed as active for fuel pump circuit short. The other one, the next one, it's P025A. It's in the history, but it's fuel pump module activation electrical fault circuit open. As far as the part of descriptions for that 3044, you can read some of this, but basically it is describing something to the extent of a short circuit from B plus and ground between the fuel pump, control module, and the fuel pump itself. And as far as this description here, basically tells you to unplug it, recheck for codes. If it goes away, it's telling you that the pump's possibly faulty. If not, obviously an issue with the control module lines down to the fuel pump. As far as this next one, the 025A, it's as far as the causes, it's almost telling us a little bit different things as far as possibility. As you can tell there, more of the control side of the actual pump, not so much related towards the pump. Now, being that I haven't had a chance to diagnose one of these for one of these type of issues, I don't want to just shoot from the hip and basically throw a fuel pump in it, because I know these have a control module on top of that, and that module will receive a command from the actual engine control unit that's going to be a pulse width signal. And then, so the fuel pump control module then is going to control the fuel pump itself, which in this case, again, is a 3-phase motor pump. So there's 3 items there that could potentially be causing an issue. So again, and I'm sure you can imagine any of those 3 are probably not going to be cheap. So I don't know 100% how I'm going to attack this, but I want to try to identify an actual problem instead of guessing and throwing parts at it. So I think just for starters, I am going to simply just gain access to the fuel pump, tap into the phase lines without unplugging the fuel pump yet, and just taking a look at the waveforms that I'm getting while the fuel pump is operating, just to see if I see anything weird or oddball, to try to make some sort of decision. Obviously we know that the module is going to control the pump, so we want to see control present on the 3 phases, and I'm going to tap in on both voltage and amperage so that we can see, hopefully with amperage, some movement or some type of movement, voltage, some sort of control on all phases. So again, not 100% sure what I'm looking for, but I'm gonna start with this. And also because it was one of the easier options to gain access to and get a good picture at the final, let's call it, product that's in this fuel system. Okay, obviously I've got all my connections made, running the scope. And I won't even key it up for right now. I'm just gonna close the door, open the door, and there I heard the pump kick on. So we'll take a look at some of these and see what they look like. Okay, so here is that capture of the fuel pump waveform, and clearly we've got our 3 legs in voltage, and down here I've got amperage of the 3 legs. I'm doing this again to just try to see at the moment if there is anything crazy or funky that is basically initially dropping out. That's why I'm monitoring all 3 legs at the same time, and based off of basically the trouble code and for what it's logging is for either a short or open or any of the sort, is why I am again just tapped in, and I want to see something disappear or shoot up and short out or bottom out, short out. So something odd, and that's not showing up at the moment, and there's not much. Even if we blow it up, you're just seeing the activation point occurring. And so at this point, because we've got a fuel pump that's involved along with the fuel pump control module that controls the pump, and we're seeing the control occur from the module. We're seeing the pump being activated and working. There's nothing right now that stands out. Now, yes, it's plain as day this portion here is different than these two. Now, is this something to worry about? I'm going to be honest, I don't know 100%. And then here in the lower section, in amperage, there's one of them that is odd as well, or not odd, but let's call it different. But it totally does not disappear as, again, it's shorted out or open circuit or whatnot. And so there's not really anything that is standing out. And again, I don't know 100% what I'm looking for. And so I have to try to decide now where to go with this. And so I want you to take a look at this. This is the connector for the fuel pump, one of the connectors at the fuel pump. But it has the power supplies for the 3-phase and the ground on this connector. And I want you to, so we've got 1, 2, 3, and the UWV, when you see that and the 3 wires, that is for 3-phase motor. That's how, obviously, in the diagram you can distinguish to tell what kind of setup you have. So keep that in mind. That's what's going to operate the pump. And so my idea is to basically substitute the pump, reactivate it, get it spinning, and see if that signal looks different. But I don't want to go buy a pump and try this, because again, if it's not a pump, so on and so forth. So I think I can set something up where I can get this operating. At least I want to try and see if I can make something happen. And another pump / motor that I know is 3-phase that I do have here in the shop is the BMW Valvetronic actuator motor. It is a 3-phase motor. Now if you look at the red, we've got the U, V, and W. Again, the same legs and description as the fuel pump. And so what I want to do is plug this 3-phase Valvetronic motor. I do have a harness here. Here are the 3 wires. I can plug this in, run it to the fuel pump connector, and rerun this capture and see if that ending point in the green channel goes away. That will help me determine if it's on the pump side or on the module side. Okay, so I got my adapter harness made, tapped in, all the same corresponding legs for the Valvetronic motor, tied into the corresponding same leg on the vehicle harness. Amp clamps are turned on. Scope is running with the all the same settings and channels and everything. And all I am going to do is close the door. That should wake up the vehicle. It will command and spin the pump, which in this case is a Valvetronic motor, so we will get a signal. Okay, here we go. And now I'll open it. Alright. Okay, so now here is the capture of the Valvetronic motor. I'm not sure if you could see down there. I've got it labeled, listed, Valvetronic motor capture, basically. And so the whole point of installing and running this Valvetronic motor is I'm trying to decipher, and I'm trying to find something to change. I'm trying to look for a change to occur with a different component, and to see if anything again yet stands out in order to try to make a call. Again, I'm trying to not jump and call a pump or call a module. I mean, yes, it's easy to call some of these items, but without knowing as to why you're making the call on one of the two items, it just doesn't make sense. And so I've gone ahead, installed the Valvetronic motor, which, yes, again, as we explained, it's a three-phase motor, tapped into all the same lines. And I'm not sure if you can already tell, but it resembles the original fuel pump three-phase motor pretty close. I was surprised when I saw this, and there's that portion again that I was sort of questioning, because obviously it's different than these two legs, but it is there with a completely separate three-phase motor. And the portion down here in amperage, again, the gold is up and straight over, and so there's basically no change right now. Two separate motors, same looking pattern. Pattern is being created. We're capturing it, we're seeing it, which means the module is turning on and controlling the legs. We're getting, obviously, amperage pattern because we're getting voltage occurring, or activation of voltage occurring. And that's only going to happen if the motor is all intact, operating, and if the module is doing its job of controlling. So right now, the pump seems to not be a cause of basically trouble code being generated, because I'm not seeing any different pattern with a separate different motor. Now, is it with what's going on? There's something that I just don't know past service information or whatnot that the module itself is just not happy with. That is something I just don't know. That's left up in question. But the only thing that I do know 100% is that this pattern did not change, and it's two separate, completely different three-phase motors. Okay, so based off what we saw, I'm going to go ahead and install a new factory module and see what that does. As far as the location, it's a little bit of a pain in the behind. It is on top of the fuel tank underneath the car. So I've got it connector unplugged. We'll get it plugged in and see what that looks like. Okay, so removed the Valvetronic, connected the fuel pump back in, have the scope running with the same capture, and just side note, there is the pinouts for me when I had to figure out the correct location to the Valvetronic motor. So we'll go ahead and just shut the door. Open it up. See what that looks like. Okay, so we've got an adapter harness over to the fuel pump. Scope is running, all same channels. Go ahead and close the door. Okay, so as you clearly saw, I went ahead and, because of left unanswered questions that I am unable to verify, I did go ahead and install a new fuel pump control module. I don't have a capture of that, but you can only imagine what the capture looked like if I'm not even showing you. So past that, I decided just to leave no stone unturned or have no questions arise or question my testing procedures. I went ahead and got a factory new fuel pump and connected it outside of the vehicle. So the configurations now that I've been testing under is original fuel pump, original control module, Valvetronic motor, original fuel pump, new control module. Now, new control module and new fuel pump, all factory stuff. Here's the capture for that. You could see down there. New pump and module. And let's go ahead, take a quick gander. And nothing else has changed. All configurations that I've been testing under, everything always comes up this way. There's that portion. We clearly get some signals that come up. We have the amperage that starts off the same, is the same here, and that same yellow trace again. Everything is the same. And at this point, I am just not finding anything that firstly I am looking for is for something to be missing or drop out or not act right or act totally different than the other legs, and I'm not getting any of that. Then I'm looking for a change from the original capture of the two original components with all of these totally different, new, separate, whatever components, and there has been zero change on the waveform with any of these testing procedures. But yet we know we get continuously that trouble code randomly pop up on the customer, and I can't for the life of me find anything on the data that I'm capturing on all these waveforms, and I'm just going cuckoo at this point. Okay, so after the module did not make a difference, and the pump basically also did not make a difference when I had it hooked up outside, I basically didn't have any clear data information to make a decisive, true call of seeing something faulty, because again, on the scope waveforms that we saw, nothing changed. Even though the one section that I still didn't like did not change, it made no difference, again, whether it was a new module or original module, original pump, or new pump. So with that, the customer asked me to just basically install one and let him go for about a week and see what happens. So at that time, I decided to install the module because of the fact that if I put a pump in, it's going to get wet with fuel and so on and so forth. So we let the vehicle go, and everything was fine for a few days, and just short of a week, a full long week, the light came back on and the same code came back on. So at that point, obviously, as we know, the module did not make a difference. At some point, the computer was not happy. Same trouble codes. So because of that, there was almost, nothing else really to try, but I guess to put a pump in. The circuit, the system is simple. You have the engine computer, you have the fuel pump control module, and then the fuel pump. Obviously you have wiring and so on and so forth, but there's not much to it, and the engine computer keeps throwing these codes. So I decided to throw the pump in to just see. And so here's the original pump. The new one's installed. And there's one thing I wanted to show you. I don't know if you can hear that, but the pump did kick on. And this is what I got. Same trouble code came back. So after all that, which this was kind of just a last ditch attempt to see if anything makes any difference in its operating state. That was just the last bit of hesitation, or the unknown that I had, that if the waveforms looked different because the pump was not in fluid. So I just needed to get that out of the way. Clearly it still has a problem. This is a new pump with the original control module. Everything in all multiple scenarios, nothing has cured this problem. But I think I know what the problem is now, and so I'm gonna chase that and see what we can find. Okay, so now at this point, everything is back to original components, that what the vehicle came in with. And so we are back to square one since everything else didn't make a difference. Again, I reiterate, the scope captures show that nothing made much of a difference. So now I'm going to set up and try to show you what is going on. We'll scan the vehicle and look for the code. If it's there, I'll erase it and then I'll show you. Okay, so we're in. I've got the vehicle running. We'll check the engine computer. And we'll go into trouble code. Okay, so we have the code. Again, the P025A, it's listed as passive. So, key on, engine off. We will erase the trouble code. Okay, no more code. I'll cycle the key to the off. Turn the key back on, engine off. We will reread. And no codes. So I'll start the car. Back out. Reread in the same motion. Nothing. I'll back out. I'll turn the car off. And hopefully you can hear if it happens. I'm going to start the car again. We'll read. I didn't hear it happen. So, off. I'll start again. No codes. I'm gonna key it on just for a moment. Okay, I will go to off and try again. I think I heard it. Well, let's see. Nope. Okay. Again, I'm gonna key it on. Okay, try to start again. There we go. So, finally, after a few attempts here, capturing it live on the camera in real time, basically, it took a few crank attempts, but finally got it to happen. So we continuously are getting this fuel pump trouble code for the electric circuit, open, whatever it may be, continuously. We know it has nothing to do with the fuel pump or the control module, so on and so forth. And I can get it to happen as I just showed you. Now let me show you why this keeps returning. Cold cranking amps are extremely low on this battery. Let's see. State of charge is nearly at 0. And so this battery is very, very weak to the point where sometimes during cranking it'll almost have the dropout hesitation and then catch and continue to crank the starter and go on. It hasn't been needed to be jumped for the customer just yet, but it's something that I noticed during cranking after replacing the fuel pump. And if we look at the waveform during cranking, this is one where it cranked, it dropped down, kind of had a hesitation, and then continued to crank and start and run. But it dropped down to 6 volts. So it's been dropping a lot during cranking past a certain point. And so this whole time we've been dealing with an issue with the battery not having enough power, and during first cranking, if it drops down below a certain point, it throws a computer in the state of where it thinks, I'm sure other things are going, let's call it wacky or whatever, but for some reason it tattletales as if the fuel pump control module is like dropping out of a circuit or creating an open circuit or something in the fuel system that it thinks it's failing, when this whole time it's related to a battery power source issue. And you could look at the fuel system components all day and have no codes nowhere else for anything, and the car still start all the time, but just sometimes will have a hesitation, a hiccup, and it'll throw fuel pump system codes. This was one I chased for a while, put a lot of time in testing and looking and checking and changing stuff on the fuel system, when the whole time it had nothing to do with what's wrong with the car. Okay, so there's the old battery. I just ran a quick test, and to not bore you guys too much, it's no different than before, except for different numbers. So Clearly, that's at a 9.6 for the voltage drop, and the amps is way over compared to the last battery. So this battery clearly has a whole lot more strength in it, and so I'll go ahead, put it together. I'll actually end up driving it home tonight, get some good driving, basically meaning a lot of starting events within my possession while I still have it, just to make sure nothing else happens, and that is all that was making us have fuel system trouble codes, and hopefully those are all gone. Okay, so that's pretty much it on that one. And again, as I explained before, this one was a very difficult diagnosis, being that nothing was clearly popping up on the waveforms. And just to reiterate again, the whole purpose of me trying to test and do so much testing in so many different scenarios of testing, including adding a Valvetronic motor to, do some testing, was to avoid getting in a parts cannon type situation. This one was extremely difficult and frustrating because the code would always come back. The code is telling you fuel system related. And, working with the customer, which he was informed along the whole way, he's a regular customer and would pop in every so often for updates. And I updated him with everything that I did step by step. And he too was just, first of all, was very patient, but understanding, and was okay with, wanted to kind of just, let's put a module, see what it does, and test it under the everyday use, so on and so forth. That didn't make a difference, and was okay with, okay, let's try a pump, and just so on and so forth, trying to get some sort of answer if there was anything that we missed during testing. Clearly, we see that we didn't, and the data does back that up. Again, no parts made any difference. So I guess I got lucky to finally just kind of pay attention as to when it generated, meaning the code generated actually right after the fuel pump, and I cranked it over. I can hear that it was kind of a slow or hesitating crank, and I knew right then and there that that was going to be the issue, that the vehicle was being thrown into a crazy wigged out mode. And then I tie that with past experience again with the VW Audi group, that when there is low voltage issues on startup basically, or when the vehicle sits and you go to start with weak battery, low voltage, so on and so forth, these vehicles tend to go into a crazy mode. I'll put in the link somewhere or here on the screen an example of a Bentley, which is again the same manufacturing group and systems, and that too was a battery issue that you could look elsewhere, but it's due to battery issue. This one was again, it's frustrating as you're dealing with it, but once you overcome it and find out and finally rectify it, it becomes enjoyable, so to say. It's cool to find out the issue. It's cool to rectify it, to have the problem taken care of, and also again to not overspend when you don't have to. That's my main goal here at the shop, is to I try to preach that and go that route. Again, with some of these parts, the customer is not responsible for any of that. It's all on me. But again, like I said, we kind of knew those were not going to be the issue anyways, but the customer's being treated correctly, properly, charged accordingly, only for basically diagnosing and dealing with the battery issue at this point. And but the most important thing is this weird situation is over and done with. One thing that I do want to mention that I'm remembering that I've not mentioned yet, this was occurring in our region's kind of colder months. And so if you remember, it would randomly pop up, meaning the code. and it's in the customer's possession would be fine sometimes, and then the light would come on, but those were the days or mornings that it was really cold or colder than the times nothing happened. And so that's with a weak battery, a very cold morning, cold start, voltage drops down, boom, the code pops up. That's what was going on while in the customer's possession. That's why they would get their light sometimes and it would go away and not come other times. And luckily for me, maybe I had the key on long enough to drain it while scanning or something, and then I experienced that weak cranking event, and that just led me to down the correct path. So that's gonna be it on this one. Take some good info from this. Always keep in mind about your battery strength and voltage and amperage and everything being strong, especially in VW Audi group vehicles. But with that, again, thank you for the customer for being patient. Thank you guys for watching. And this was another one that was conquered and done with. And we'll just move on to the next one from here on out.